Alberta, over 90% of rural households rely on wells for their water supply. That means roughly 600,000 Albertans use groundwater for their drinking water, whether they have a private water well or live in one of the many Alberta towns or villages that depend on groundwater from a municipal water supply well. Groundwater is also used across Alberta for agricultural, industrial, and commercial purposes. Here in Alberta, groundwater is found in superficial deposits of sand and gravel, or in bedrock layers of coal, sandstone, or fractured shale. The groundwater in these aquifers is generally protected from our land use activities because the layers of earth material above the aquifers act as a filter. However, when a well is constructed, it provides a direct conduit to the aquifer, potentially creating a pathway for contaminants to reach the groundwater. Our land use activities carry many contamination risks. For example, pesticides, fertilizers, and other chemicals used in agricultural operations pose risk from misuse, improper storage, and possible spills. Livestock manure or household sewage can cause bacteriological and nitrate contamination from systems that are poorly designed, located, or maintained. Improper disposal or storage of hazardous materials or poor management of fuel storage tanks can also lead to groundwater contamination. It only takes a few liters of gasoline to severely pollute an aquifer. A small leak of just 1 drop per second can release about 900 liters of gasoline in 1 year. Industrial site spills, pipeline breaks, even train derailments all have the potential to contribute to surface contamination that can eventually find its way into our groundwater. Natural events like flooding and fires can also have adverse impact on water wells and groundwater.
One of the things we emphasize in the Working Well program is the proper plugging and decommissioning of water wells. And if you think about it, the fastest way for a well to get contaminated is by having an old well that becomes a direct conduit from the surface for a contaminant to get right down into the bottom of the well and into an aquifer.
Contaminants can flow directly into a well when the well cap is loose, cracked, or missing altogether. Any unsealed space around the outside of the well casing, holes created in the casing by corrosion, or damage to the well casing may contribute to contamination of groundwater. These situations not only provide a direct pathway for surface contaminants to enter the well, but also create the potential for mixing of aquifers with different water qualities. Wells that are located in pits are a real concern. Inside a well pit, the well casing is cut off below ground level, and usually the well cap is either not watertight or missing altogether. Any water that collects in the pit from surface runoff or seepage from a high water table has the potential to contaminate the groundwater by seeping around the well casing or entering directly into the well. An abandoned well poses the same risk of contamination, but the impacts often go unnoticed until neighboring wells that are tapped into the same aquifer begin to display symptoms. By that time, contamination of the aquifer may be severe, and cleanup will be expensive and time-consuming. It is imperative that we do whatever we can to reduce these risks and prevent groundwater contamination. Provincial regulation requires current well owners to decommission water wells that are no longer in use. However, recent studies show the majority of well owners have a false sense of security when it comes to the safety of their water wells. They often don't take the precautionary measure of decommissioning old unused wells because they are not aware of the inherent risks that these wells pose. Also, procrastination and a lack of knowledge about what is involved in the decommissioning process seem to be more significant barriers to decommissioning than the expense that will be incurred. It is important that well owners understand all of the risks abandoned wells pose. For instance, large diameter wells that have been abandoned are not only a contamination risk, they are also a serious safety hazard. There have been too many incidents where animals or people have been injured or even killed after falling into them. Many old farmsteads and rural properties may have at least one abandoned well. How do you know if there's an abandoned well on your property? You could look for well records in the Alberta Water Well Information Database. Since the mid-70s, water well drillers have been required to submit well drilling reports to the Groundwater Information Centre of Alberta Environment and Parks to be added to this database. However, older wells may not have been reported, so there is no public record of their existence. You can access the database online or call toll-free for assistance. You could also talk to previous landowners or long-time area residents about potential locations of old wells. Walk around your property and look for evidence of abandoned wells. An old power pole or an electrical panel that has been disconnected. A pipe sticking up out of the ground. It could be in your yard, in the basement of your house, or through the floor of a barn or other building. An old piece of plywood or metal lying on the ground, possibly with rocks or debris piled on top. A ring of concrete or bricks surrounding a hole in the ground. A dip in the land surface or a circular depression. Old outbuildings, sheds, windmills, wishing wells, hand pumps, or hydrants are also possible signs. A pit in the yard or basement of your house, or a basement offset, or an abandoned yard site. When is a water well considered abandoned? The following criteria may help you decide. Is the well no longer in use and not intended to be used in the future? Is the well no longer being actively maintained with annual inspection, disinfection, or testing of water quality? Is the well in a poor state of repair? Has the pumping equipment been removed from the well, or is it irreparable or obsolete? Is the well unable to produce water, making it no longer an asset to the property? Decommissioning a water well is not as simple as it sounds. In Alberta, the standards for decommissioning are set out in the Wells Directive of the Water Ministerial Regulation. It can be a complex procedure, so it is important to hire a certified journeyman water well driller. Not only will they know the current regulation standards, they will also have the expertise, equipment, and experience to do the job right. If you don't use the correct plugging materials and have them properly placed into the well, you could end up with a poorly sealed well that continues to allow contaminants to enter into the groundwater. Limited access to the wellhead often makes it particularly difficult to decommission a well. Examples of this are when a well is located inside a pit or building, in a remote location, or surrounded by obstacles like trees, buildings, or fencing. Other situations can also complicate the decommissioning process. For example, wells that contain obstructions like damaged pumping equipment, rocks, or debris can be a challenge. Flowing wells from which water flows freely without the aid of a pump can also be difficult to properly plug, as they often require different materials and methods for successful decommissioning. Many factors must be taken into consideration before decommissioning a well. Site conditions, local geology, hydrogeological characteristics, and well construction details are all important things to think about before deciding what type of plugging material and placement method to use. Before the well is filled in, all pumping equipment should be removed if possible. The well needs to be flushed out, and any remaining water in the well must be disinfected. Next, you need to gather information of the well, including the total well depth, casing diameter, and the static or non-pumping water level, all of which can be found on the drilling report if available. The driller will also take current measurements to compare with the available historical records. These details will be used to determine the volume of plugging material needed to properly fill the well. Plugging materials must be uncontaminated and impervious to prevent any future movement of water within the well. Slurry grouts of cement or bentonite clay can be mixed up and pumped into the well, introduced at the bottom using specialized equipment, and placed progressively upward to the ground surface. Alternatively, bentonite chips or pellets might be used. They are manufactured specifically for pouring directly into the well and can be used very effectively in some circumstances. When using bentonite chips, the driller should pass them over a screen before they go into the well to remove any fine particles. This technique reduces the chance of the bentonite bridging off and helps ensure the well gets completely filled from the bottom all the way up to the top. Pouring the chips in very slowly is critical. Each well decommissioning project is going to be different. Your driller will decide the most appropriate sealing material and placement method to be used to achieve the best possible plugging of your well. Experienced water well drillers will tell you every well decommissioning has its own unique challenges.
There's a couple different methods of abandoning wells, and the driller may suggest one way over another because of accessibility issues. Sometimes an old well is in an old well pit or in the basement of an old house where it's not accessible for a drilling rig to get in. So he may use bentonite chip pour from the top method over, pull the casing out and run a tremie pipe in and use a pumpable grout. If it's wide open and there's lots of space where the driller can get his drilling equipment in, then he'll pull the liner out and run drill pipe in or a tremie pipe and pump from the bottom up and abandon it that way.
Sometimes a driller will remove the well screen or perforated liner as part of the decommissioning process. While this is ideal, it isn't always possible. Any casing that is left in place must be cut off a minimum of 0.5 meters below ground level. And once the well has been sealed up, the excavation made around the well to accommodate cutting off the casing must be backfilled up to the ground surface with clean fill material. Decommissioning a well located inside a well pit or a building requires special attention because of the safety hazard a confined space presents. The air within the pit or building can become oxygen deficient or may contain gases like methane that might be naturally occurring in the groundwater. In Alberta, there are several documented cases of well pits and buildings that have exploded due to the buildup of gas. Tragically, people have also died from asphyxiation after entering oxygen-depleted well pits. After a well in a pit is plugged, the pit should also be removed. To do this, the driller will line the bottom of the pit with a layer of bentonite chips to create a seal, remove the pit structure, and backfill the excavation to the ground surface with clean, compacted clay. The decommissioning process is even more complicated for a well located inside a building, especially if the building cannot be removed. Bored wells with a diameter greater than 24 inches also need special consideration during the decommissioning process because of their size and the sheer volume of material required to fill them. Often, drillers will suggest clean, uncontaminated clay as a lower-cost alternative for the plugging material. It can be shoveled into the well but must be done carefully to ensure the clay reaches the bottom of the well and seals all empty space. After the well is filled, the cribbing must be cut off at least 0.5 meters below ground surface and topped up with bentonite to ensure an effective, watertight seal.
We use bentonite chips in the well to prevent vertical movement of water within the borehole and also to prevent surface water from contaminating the well at a later time.
Once the decommissioning procedure is complete, the well driller will submit a decommissioning report to the Groundwater Information Center. The details from the report are stored in the Alberta Water Well Information Database to reflect the well's decommissioned status. Decommissioning an abandoned well is done to return the site, as much as possible, back to its original condition. It is estimated there are more than 300,000 inactive or abandoned wells in the province. Properly plugging these wells removes the threat of contamination and protects the resource that many of us use for our drinking water supplies.
You get a new well drilled, and now 3 months later you got contamination coming across from this one. Well, you got the same problem you had when you started. So you may as well get it done, and at the end of the day, it's the law.
Protecting groundwater is a shared responsibility. We should all do our part to preserve this valuable resource for generations to come.